Hello students, welcome to the next lecture on the CSIR NET 2020 mathematics. Today in this lecture we will see the questions related to the complex analysis, and we will discuss about all those 8 questions which was asked in this paper with the shortcut tricks. So let's start with this video. So the first question is related to them. So whenever there is a integration, whenever the question is asked in the related to complex analysis of the integration, you have to apply either as a Cauchy integral formula or you can apply the residue theorem. But how you can do it in the shortcut trick is, firstly you have to draw the graph of this domain. What is the domain is? Center is my 1, 0, radius is my 1. So it means this is my figure of this problem. Now you can see what are the poles, what are the roots of this denominator. So it will be my 1, it will be omega, so omega will be my here, and third one is minus of here. All of you know that roots are my 1, omega and omega square. Now you can see which one lies here. So 1, it lies inside this circle, that's fine. Minus half and plus this is outside. It means the function at this point is analytic, so the integration will be 0 at this point. Minus half minus root 3 lies here. Again this is the analytic, function is 0. So the only point is the function is undefined at z is equal to 1. So therefore whatever you have to write this form of this. Now you can substitute z is equal to 1 in this case apart from here. So it means you can substitute the z value. Z is equal to 1 in this case, that is 1 upon 1 square plus 1 plus 1. The answer is 1 by 3 is the required task. Look at the second question, which is again parallel to the same track. So it's integration over this square. So you have to firstly draw the figure. Center is my 1, radius is my half, so it's half, then it's a 3 by 2. Now you can find the roots of this. Z square is, that's a plus 1 or minus 1. Also you can see this part becomes infinity, the function becomes infinity when z is my 0. So there are the 3 points are there. Now you can check that z is equal to 0 lies outside this one, so that's the integration is 0. Z is equal to 1 lies inside that, that's fine. Minus 1 lies outside that, so that's a 0. It means the function has a singularity at the point z is 1. So I can write this function as of here form. Now corresponding to z is equal to 1, that is for here, you can substitute this value apart from z minus 1. So what is the answer is 1 e raised to power 1 upon 2, that is e by 2. Now since there is no 2 pi iota is present, so I can multiply this by 2 pi iota. So what is the answer is e pi iota. You can see in the previous case this is the 1 upon 2 pi iota is present, so there is no need to multiply that. Look at the another question is there. So function is given to you holomorphics. What is the meaning of the holomorphic is there? So f is holomorphic. What is the meaning of that? F is differentiable over the complete domain. Now f has only the zeros over having multiplicity this. So that's a very simple task are there. You should remember this concept. I think you have studied this one also. So if you have a function of like this way, what is that? This is nothing but my you can say these are my ai, number of the poles, minus g of b, bi, and number of the here. What is the meaning of that? A is my zeros, n is my number of the, that's a multiplicity, these are the number of the poles, b is my number of the poles, and it's a multiplicity of the pole. Now what is that? F is holomorphic. It means f is differentiable. What is the meaning of that? There is no pole of this function. When there is a no pole of this function, what is the multiplicity of this one is 0. Since this is over I, so it can be written here. So pi is 0. So it means this expression is nothing but my function of here and ni. Now what is the n is multiplicity of the 0. So how many zeros are there for this function f? It is given that f has only zeros. Again it clears that there is no pole that, so p is 0. F has only 0 at z is equal to 0. It means it has only 1 0. So it means the summation part will be ruled out. Zeros at the point z of this. What is the multiplicity of this 0 is q here. So the right answer of this will be my q of g of z0. Now you can find the value of the g. You can compare this function with here. What is the g of z? It is nothing but my z raised to power p. So what is the right answer of this? This is q z raised to power p. Which one is the right answer? Is the A is the right answer. So you should remember this beautiful results so that it may be help you for the future one. Look at the another one is there. So what is given to you? Again, it's a holomorphic function. So it means this is a differentiable over the domain, over this domain, and there is a no pole B. What is given to you? F of 0 is my 0, f dash is 0 is again a 0, and your target is to find the f of this value. So what is that? So look at that. F of 0 is 0, f of dash is 0. Look at the point is my constant, same value. What about the second derivative? They are not given. It may be 0, it may not be 0. What is the meaning of that? So do you remember that? What is the concept behind that? If f is a 0 of order, say m, what is the meaning of that? It means the first derivative 0, second derivative 0, f is also be a 0, and m minus 1 derivative is 0, but m minus 1 mth derivative is a non-zero. Then only you can say it is of order m. So same thing for here. So in the complex analysis, if you have the function f of z which is holomorphic, then and f of z is less than 1, first property, and second property is if f has zeros, f has a 0 of order m, then you must remember this result is there. F of z is less than or z raised to power m, and mth derivative of this, it must be less than or equal to m. So we can use these two results and then we will try to find. So you can see our target is to f of half. So look at this property satisfied. F has order of m. This is also be satisfied. M can have any value. So what is the value of the f of half? It will be less than or equal to half raised to power m. Now our target is to find the value of m. So you can see these two values are given. What is that second derivative at 0? It may be 0 or it may not be a 0. It means, what is the meaning of that? F has at least 2 order B. At least f is at least of the 2 order. So I can take m start from the 2. If I take m is 2, this is by 1 by 4. Modulus of is my 1 by 4. What is the meaning of that? Minus 1 by 4 less than 1 half less than of 1 by 4. So these two options are the correct. Is 1 by 3 satisfied? No. It means these options are cancelled out. On the other hand, if you consider m as a 3, what is that? This is my minus 1 by 9 plus 1 by 9. Again these options are discarded and so on. So at least this value is considered for m is 2. For m is equal to 3, none of the values. So it means what are the possible values? So 1 by 4, 1 by minus 1 by 4 are the possible values. So you should remember this result. Look at the another one is there. So what is given to you? Function f of z is greater than equal to 1. F of 0 is given to you as a iota. So what is the value of the f of half? So in this case, you can see there is no question about the order of the m. While in the previous one, they are asking about the derivative also. So that's why there is a concept of the zeros of the order. But here there is no derivative. So what is that? You can see here what is given to you. F of 0 is iota. Firstly, we will check whether 0 belongs to the D or not. You can check 0 is less than 1. That's 2. It means 0 belongs to D. It means whenever, it means what is the meaning of that? It means this function is a part of this domain. So what is that? I can consider here. So if this is a part of this, what is the value of the f of half? That's a constant are there. So that is our right answer is here. Look at the another one is there. So if you have a function f of z which are the following are true, so it may have the more than one answers. So if you think about that, all are my 0, they are thinking about the 0. So what is the definition of the zeros? F of z is my 0. So can you find the value of z from here? This is e raised to power, this is 1, 1 when it will be 1, so I can write this as of 2n pi iota, 2n pi iota. So what is the value of the z are there? So I can write this as of 1 upon 2n pi iota for all n in the integers. So what is the value of the z? Z can be written as 2n pi iota minus of this. So for all n in the, so these are my zeros. Now what are the questions? There are finitely many zeros. So look at that. Z has infinite. So how many n's are there in this set? They are infinitely. So once n is infinite, so it means Z has infinite zeros. So it means first option is cancel out. So now second one is the removable pole essentials are there. How you can do that? You can simply use this concept. You can find the limit points of the zero. So what is the limit point of the zero? Says that it always set to the non-isolated essential singularities. But if you find the limit point of the pole, what is give to you? This give you the essential singularities, isolated essential singularities are there. So what are the limit point of this? If you take the limit z approaches, n approaches are infinity, what if happen? This will be 0. So what is that? This is minus of iota. So it is a non-isolated. So the poles has a removable singularity, that's cancel out. Pole is cancel out. So this is the right answer of this problem, because limit point of the zeros, the sequence, that is the limit point of the zero, converges to the non-isolated. So it's essential are there, whether it's isolated or non-isolated. So the right answer is my only D. Look at the last question are there, which is again of the 4.75, and that's a very simple task are there. You have to find this value. So what is given to you, that this here, sorry, what is given to you, that is this point is given to you. You have to find the value of this theta which are satisfying this equation. So you can substitute this value in here. So what is that? This will comes my Rn e raised to power n iota theta. I can rub it again. So this is r raised to power n e raised to power n iota theta plus 1 modulus, which is, what is the modulus of the z? What is the modulus of the z? Is only r. So it means this is here. So I can write this as r raised to power n iota n plus 1. This is nothing but r n minus 1. Now you can, what is the modulus value of the z? This is x square plus y square. If z is my x plus iota y, that is a real and imaginary. So what is that? What is the real component of this? Is r n cos n theta. This is real square, plus what is the imaginary part? Is r n sine of n theta, which is nothing but r n minus 1. So if you scaling both side and if you open this bracket, what will happen? This is r of 2n plus 2ab of this. What is that? This is rn plus 1 minus of 2rn. That is a scaling on both sides. So what is that? R1 will be cancelled out. This is cancelled out. 2rn will be cancelled out. So what is the answer of this? Is cos n theta is my minus 1. Is there any right answer? Yes. So answer C is the correct option. So this is the way you can solve all these 7 questions related to the complex analysis which was asked in this December 2020 CSIR NET. I hope you can learn this here and apply in this future examination. We will see some more questions in our next class. Till then, you can simply follow this link for finding the various videos. Best of luck, students. Happy learning.